Okay, so now we're going to talk about the periodic table. And this is actually probably, aside from your calculator, probably the most useful tool you will use all year. So a periodic table is got a lot of information on it if you know how to use it. So I'm going to show you how to use it. How it's organized. So it's separated into three large groups. Metals, semi-metals, or metalloids, they mean the same thing, and then non-metals. And if you look at the periodic table, the metals are by far the largest group of elements. There are at least 88, and it's growing. Every year somebody makes something new. Most of them are solids at room temperature. Mercury is a liquid. So the way it breaks down, if you look on the periodic table that I have hanging in my room, there's this thing, we refer to it as the staircase. And the staircase divides the metals from the non-metals. Now the ones that sit on top of the staircase or underneath the staircase are considered to be semi-metals. This one's radioactive. No one really cares about it. And aluminum is definitely a metal. But the majority of them that either sit on top of the staircase or sit below the staircase are referred to as semi-metals or metalloids. And the metals are located to the left, non-metals are located to the right. Metals have the following properties, and this is just kind of a quick summary. They tend to be a solid. Again, mercury is a liquid. There's another one that if you put it in your hand, it'll melt. So body temperature is a little higher than room temperature, but it'll melt in your hands. It's called gallium. They tend to have high melting points. High tensile strength means you can hit them and they don't break very easily. They are good conductors of heat and electricity. They tend to be shiny. Malleable means they can be bent without breaking. And ductile means they can be turned into a wire. Sonorous means they make noise when you hit them. And they have a high density. They're packed pretty tightly. Okay, nonmetals, on the other hand, are poor conductors of heat and electricity. They are generally not shiny and definitely not ductile, and they tend to have low densities because most of them are gases. Well, a number of them are gases. Nonmetals are on the right side of the staircase except for hydrogen. Hydrogen's on the left side, and it's above lithium for a different reason. At room temperature, these guys are your solids. Br is a liquid. The rest are gases. Okay, so the entire last column, helium, neon, argon, krypton, xenon, radon, are all gases. Fluorine and chlorine and oxygen and nitrogen are all gases. So they kind of vary a little bit, unlike the metals, which are mostly solids. So these are your nonmetals. And again, remember my staircase, right? Divides them. So the diatomic elements, some of the elements that you find in nature exist paired. It's like Siamese twins kind of thing. These 7 elements, there's little tricks to remember them. But it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They all exist naturally doubled up. So if you find them as an element, they are still an element. Even though they have a little subscript, they have one capital letter, makes them an element. But the fact that it's 2 means they exist in nature doubled up. Okay, there's a couple of ways to remember them. If you look on your periodic table and you make the number 7, like this, starting with nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then throw in hydrogen. There are 7 of them. 1, 2, 3, 4, 5, 6, 7. And 6 of the 7 make a number 7 on the periodic table if you include hydrogen. That's one of the ways. The way I usually refer to it is I refer to them as Brinkelhoff elements. The Brinkelhoff elements exist doubled up. Okay? Semi-metals are the metals elements above or below the staircase, but again, watch out for that aluminum. Aluminum is definitely a metal. They tend to have properties of metals and some of non-metals. Polonium is radioactive. No one really worries about it. Some are semiconductors. All of them are solids. So again, aluminum is right here. It definitely qualifies as a metal. Now we're going to talk, I think, about those 2 rows at the bottom, how it's organized. So each row going left to right is called a period. They're numbered 1 through 7, top to bottom. Each column, that means going down, is referred to as a group or as a family, and there's a reason for that. The elements in each family have very similar physical and chemical properties due to the fact that they have the same number of electrons in their outside shell of the atom. And if you remember that from physical science, that's great, and if not, we'll get to it later. Each column is numbered left to right from 1 up to 18. Now, if you look on some older periodic tables, you might see some Roman numerals, but this is the official way to do it now. And some of the families, again, this is columns going top to bottom, have special names. So the periodic table families are alkali metals are in column 1, except for hydrogen. Hydrogen is not an alkali metal because it's not a metal. It's a nonmetal. It's in that column for a different reason. Alkali metals are very reactive. They are shiny. They are soft. That means you can cut them with a knife. They react with practically everything. They easily form a 1+ charge when they form an ion, and they only have 1 electron in their outer shell. The second family is in column 2. It's referred to as the alkaline or alkaline earth metals. So it's a little bit different name. They are frequently found in the dirt, so like calcium, magnesium, and they form a basic, which the word for basic is alkaline, solution in water. You put them in water, they turn into a base. They are also metals, but they're not as reactive as the alkali metals. And they are harder and more dense. That means you can't cut them with a knife as easily, but they do form a positive 2 charge. And they have 2 electrons in the outside shell. Then the next group we're going to talk about is kind of a big group. It's groups 3 to 12. It's that big square in the middle. They're called the transition metals. They have properties that transition from those like in column 2, the alkaline earth metals, right? More dense, not as reactive, to properties more like column 13, which we'll get to in a minute. Okay, they do form cations. That means they're always positive ions. They don't have one consistent charge, and that makes it difficult. Zn does form a positive 2 ion. Ag does form a positive 1. At the bottom of the periodic table, there are 2 rows, atomic number 57 to 71 and 89 to 103. They're referred to as the inner transition metals, because they belong inside the transition metals between either Ba and HF or between Ra and Rf, depending on which row they fall into. They are called the inner transition metals, or sometimes called the rare earths. The individual group here is referred to as the actinides because the first element in there is actinium, and 89 to 103 are called the lanthanides because the first element in there is called lanthanum. 13 to 16 don't have any special names. They are referred to as by the elements at the top of their group. So they generally form ions of the same charge if they're in the same family. So column 13 is referred to as the aluminum family, not boron. Boron really just doesn't do a whole lot. These elements tend to form a positive 3 charge. Carbon family is column 14. If it's a metal, they tend to be positive 4. If it's a non-metal, they tend to be negative 4. It depends on if they're a metal or not metal. 15 is the nitrogen family. Gets a negative 3 charge. And 16 is the oxygen family, a negative 2 charge. Column 17 has its own name. It's referred to as the halogens. They have very reactive tendencies. They react with almost everything. They form a negative 1 charge very easily. They are all diatomic. Remember our Brinkelhoff? And they have 7 electrons in their outside shell. Column 18 is referred to as the noble gases. All of them are a gas. They are very stable. They don't react with anybody. That's why they're considered to be noble. They don't do anything. They just kind of sit around and watch. They have 8 electrons filling their outermost shell, except helium, which has 2, but they're all full. They do not form ions. In other words, the protons equal the electrons all the time. Charge is 0. And they are all gases at room temperature. And noble gases because they're too good to react with anything. Sometimes you can make compounds with Kr and Xe, but none of them for these guys. They're just too stable. So there's this. You guys are going to want to make sure you have this for your worksheet today, because we're going to talk about, you're going to add a whole bunch of stuff onto your periodic table so that you have all that information right there handy.